IBESS Climate Change and Energy Production Part 6 examines the greenhouse gases, their origin, and their contribution to climate change. Then we will take an initial look at the effects caused by an increase in greenhouse gases. Part 7 drills in on the effects of climate change. Significant ideas are: human activity has contributed to recent climate change, and secondly, climate change causes widespread and significant impacts on a global scale, and lastly, there has been significant debate about the causes of climate change. Here is the outline of all the available movies in the Climate Change and Energy Production Unit. Use this outline to find the movie you need for review. This movie is focused here. And remember that this movie takes an initial look at the effects of climate change and some mitigation strategies. Here are the two IB syllabus statements that drive this movie forward. Human activities are increasing levels of greenhouse gases, such as carbon dioxide, methane, nitrous oxide, CFCs, and water vapor. Greenhouse gases are those atmospheric gases that absorb infrared long wavelength radiation, causing global temperatures to be higher than they would otherwise be. Can you list 5 greenhouse gases? As we move forward, it's important for you to remember to keep straight the pollution problems that we've studied. CFCs appear in our study of climate change, but do not confuse their role here with their role in stratospheric ozone depletion. Nitrogen oxides play a role in acidic deposition, but also play a role in climate change. But the oxides of nitrogen are different. Pay close attention. Be thoughtful. Also remember, greenhouse gases keep the Earth warm. The greenhouse effect is positive for a habitable Earth, but it is the increase of these gases that is the problem in climate change, the enhanced greenhouse effect. Here is a list of 6 greenhouse gases, and I want you to memorize the first 5 in the list. It might interest you to learn that tropospheric ozone, the same ozone we studied as a part of smog, is also a greenhouse gas. But remember to keep the details of each pollution issue straight. Now, all of these gases absorb long infrared wavelengths radiated by the Earth, and they re-radiate the energy back to the Earth to keep the Earth warm. Now, it's important for you to understand the source of these gases. The human activities that enhance the concentration of these gases in the atmosphere are, for carbon dioxide, fossil fuel combustion, and deforestation. For methane, it is the anaerobic decomposition of organic matter in rice paddies and in the guts of cattle. For dinitrogen oxide, nitrous oxide, fertilizer use in agriculture. For chlorofluorocarbons, CFCs, it's the use of refrigerators and air conditioners, solvents and fungicides and aerosols. And for tropospheric ozone, it is smog formation. Climate change is being driven by an increase in these gases. Here is a slide with 4 greenhouse gases. Water and tropospheric ozone are missing, and you can see that over the last 50 years, there's been an increase in carbon dioxide, an increase in methane, an increase in nitrous oxide, and an increase in chlorofluorocarbons, along with a slight decline since the 1987 Montreal Protocol. Now, it is an increase in the concentration of these gases in the atmosphere that is driving the enhanced greenhouse effect, driving climate change. This slide shows you 5 greenhouse gases. Water is missing. Notice the increase in concentration over time since pre-industrial times. Now, it's important to note in this column that each gas does not warm the atmosphere equally. Each gas does not have equal effectiveness in absorbing longer wavelengths. This is known as GWP, global warming potential. Methane, nitrous oxide, and CFCs all have greater global warming potential, GWP, than carbon dioxide. But the magnitude of carbon dioxide entering the atmosphere from fossil fuel combustion results in carbon dioxide having the largest contribution to climate change. Water vapor and methane are the next most important greenhouse gases in contributing to climate change. Stop the movie now and study this slide. This graph shows the concentration of carbon dioxide in the atmosphere over the last 50 years, with a general increase in the concentration of CO2. This data is well documented by monitoring stations in Hawaii and Australia. Scientists do not dispute this data. The yearly fluctuations relate to changing seasons in the northern hemisphere. The high value in any one year is caused during winter in the northern hemisphere when little photosynthesis occurs, and the dips in any given year occurs in the summers in the northern hemisphere as plants actively take up carbon dioxide by photosynthesis. But the overall trend, an increase in CO2 over time, results from human activities, fossil fuel combustion, and deforestation. Now keep in mind that there are climate skeptics, climate change skeptics, that think humans are not responsible for the increase in atmospheric CO2 levels seen here. I've mentioned this in part 5 of this series, and I'll mention it again at the end of this movie. The increase in CO2, a greenhouse gas in the atmosphere, is the primary gas driving climate change. Here is a table showing the carbon dioxide emissions per capita, per person, per year in metric tons. And what we see is that wealthy societies are more responsible for emitting a large amount of carbon dioxide. Each U.S. citizen is responsible for 19.4 metric tons of carbon dioxide into the atmosphere per year. This value is derived by taking the entire fossil fuel combustion in the U.S. and dividing by population. Thus, as an American, I am responsible for 19.4 metric tons of carbon dioxide emitted to the atmosphere as part of my relationship with an industrial, high-consumption society. Here is a list of human activities that increase greenhouse gases. Burning fossil fuels emits CO2. Deforestation results in more CO2 in the atmosphere. Rice and cattle farming releases methane. The use of CFCs in refrigerators and ACs releases CFCs. And the use of nitrogen fertilizers release nitrous oxide. Cement use releases a lot of carbon dioxide. Get to know the human activities that accelerate climate change, and get to know the greenhouse gas released by each activity. If you understand the activities that accelerate climate change, then mitigation strategies become easy. The primary human activity increasing greenhouse gases would be fossil fuel combustion. We've been speaking about fossil fuel combustion and its implications for most of this course. Deforestation, removing trees that would otherwise take CO2 out of the atmosphere, would result in more CO2 in the atmosphere. And if land use patterns change, for example, we replace a forest to grow sugarcane and we burn the forest in the process, the atmosphere is likely to gain carbon dioxide. Rice and cattle farming, with the anaerobic digestion of organic matter in the watery decomposition occurring in rice paddies or in the guts of cattle, releases methane to the atmosphere. Methane is also released as tundra permafrost thaws. Keep this in mind. Increased levels of methane would cause more warming. More warming causes more thawing of the permafrost, causing more methane release, causing more warming. This is a positive feedback loop that accelerates climate change. Landfills have anaerobic decomposition that also produces methane. The methane is released to the atmosphere or could be piped for local energy needs. CFCs, while reduced significantly due to the Montreal Protocol of 1987, are greenhouse gases while they are in the troposphere. Keep this in mind. And their release due to CFC use in refrigerants and air conditioners contributes to climate change. The overuse of fertilizers in agriculture results in nitrous oxide, N2O, going into the atmosphere N2O is a greenhouse gas. Water vapor is also a greenhouse gas. Don't forget this. And it's the most abundant greenhouse gas of all. It's the vapor that is the greenhouse gas, and the vapor is not visible. What we see in these images is cloud or condensed water. That said, the formation of clouds by condensation is evidence of the presence of water vapor. But there are two potential feedback loops related to water vapor. And the positive feedback loop goes like this. Water evaporates, and this causes more warming, causing more water to evaporate, causing more warming, causing more water to evaporate, etc. Now there is a negative feedback loop, and it goes like this. Increased water vapor causes more clouds to be formed through condensation. Clouds reflect light due to their high albedo, serving to cool the Earth, resulting in a negative feedback loop. Remember albedo from the atmosphere unit. Clouds reflect light, serving to let less solar energy reach the Earth, thus cooling the Earth. So, water vapor might serve to cause more warming as the Earth warms, or vapor condenses to cloud and the Earth might be cooled. The magnitude of either the positive or negative loop involving water vapor and cloud cover is not known, and this adds to the uncertainty in predicting climate change. This IB syllabus statement should now make sense. Global climate models are complex, and there's a degree of uncertainty regarding the accuracy of their predictions. Here are the greenhouse gases resulting from human activities, and you can see the significance of carbon dioxide. Can you state one or more human activities that cause an increase in each gas in the atmosphere? But don't forget that water vapor is also a greenhouse gas, and its abundance in the atmosphere is quite high. But abundance is not everything. Remember global warming potential. Methane's contribution to climate change is significant, given both its increase in the atmosphere and methane's global warming potential, the GWP. Stop the movie now to study this slide, because it not only provides information on global warming potential, but it also gives information on the human activities responsible for each gas. This slide shows the greenhouse gases and their relative contribution to climate change. It's a value that combines their increase in concentration and global warming potential. Stop the movie and take some notes. So what will be the effects of an increase in greenhouse gases? What will be the effects of the enhanced greenhouse effect? There will be an increase in mean global temperature. There will be an increase in the frequency and intensity of extreme weather events. There will be long-term change in climate and rising sea levels. In the next movie, we will examine in detail the effects of an increase in mean global temperature, climate change. Here in this list, be careful, I'm stating the effects of an increase in greenhouse gases. As seen in the red bars in this graph, there will be an increase in the mean global temperature. Notice the correlation between the increase in carbon dioxide over the last 100 years and the increase in the mean global temperature. There will be an increase in the frequency and intensity of extreme weather events. There will be long-term change in climate. This slide suggests that in the future, the green areas will be our food-growing areas, and these areas in yellow will be deserts. There will be a rise in sea level due to the thermal expansion of water. Ocean waters will rise more due to the thermal expansion of water than because of the Greenland or Antarctic ice sheets melting. Take note. So now that you understand some of the causes of increasing levels of greenhouse gases and a few of the effects, let's take a brief look at this IB syllabus statement, a statement that I will strengthen in Part 8. Discuss mitigation strategies that deal with the impacts of climate change. We will use the framework for evaluating pollution management strategies. Remember, following down along the left is the sequence of events in pollution formation: production, release, and impact. Mitigation strategies can be aimed at reducing production, reducing release, or reducing impact. Stop the movie now to study this slide. Listen carefully as I read a bit of IB ESS syllabus. Pollutants are produced through human activities and create long-term effects when released into ecosystems. Strategies for reducing these impacts can be directed at 3 different levels in the process: altering the human activity, controlling the release of the pollutant, and cleaning up the pollutant and restoring damaged ecosystems after pollution has occurred. Students should be able to show the value and limitations of each of the 3 different levels of intervention. In addition, students should appreciate the advantages of employing the earlier strategies over the later ones and the importance of collaboration in the effective management of pollution. Strategy 1. Altering human activity by developing alternative technologies. Replace industrial fossil fuel energy with alternative solar power energy, in this case, wind. This would reduce the amount of carbon dioxide released into the atmosphere, reducing the impact of climate change. Strategy 1. Alternative technologies. Using alternative energy sources that would reduce the burning of fossil fuels. This would reduce the impact of climate change. Strategy 1. Adopting alternative lifestyles and values. Altering human activity through education, incentives, and penalties. Can we reduce our use of energy, reduce the energy produced through the burning of fossil fuels? This would reduce the amount of carbon dioxide we release into the atmosphere. And in this slide, you can see images of mitigation strategies that we can employ to reduce the impact of climate change. Alternative lifestyles and values. Strategy 1. Carpooling, public transport, and an increase in human power would reduce our energy needs, reducing the amount of carbon dioxide released into the atmosphere, reducing the impact of climate change. Alternative technologies. Strategy 1. Replacing fossil fuel electricity with nuclear power electricity. Nuclear power does not release greenhouse gases, but nuclear power is very controversial because of the potential for nuclear accidents and the difficulties in storing the radioactive wastes. Alternative lifestyles and values. Strategy 1. Reduce meat eating to reduce methane emissions. Eating less meat will mitigate the impact of climate change. There would be less methane, less deforestation, and less resource required to produce food because we would not lose energy as we fed animals. Ode to the second law of thermodynamics. Strategy 1. Adopting alternative lifestyles and values. Can we reduce wet rice paddies to reduce the release of methane, a greenhouse gas? Is this possible? Consider food production in less economically developed countries. Alternative lifestyles and values. Strategy 1. Reduce deforestation. By reducing deforestation, trees stand tall to remove carbon dioxide from the atmosphere during photosynthesis. Reduce deforestation by eating less meat. Reduce deforestation by consuming fewer resources. Use ethanol. Ethanol originates from plants, so the CO2 released in the combustion of ethanol would be equal to the CO2 taken up to grow the plant. But should we be converting potential food-growing land into fuel-growing land? Alternative lifestyles and values. Strategy 1. Altering human activity through education, incentives, and penalties. Regulate or ban CFC aerosol cans. Find alternatives to refrigerants. Use alternative styrofoam package materials or less styrofoam package material. Alternative lifestyles, values. Strategy 1. Reduce fertilizer use, thus reducing nitrous oxide release into the atmosphere. Altering human activity through government legislation. Strategy 1. Protecting forests through legislation. Giving forests a reserve or park status maintains the trees that take up carbon dioxide through photosynthesis, reducing the impact of climate change. Okay, strategy 2, controlling the release of the pollutant. Catalytic converters in cars or filters and scrubbers on smokestacks would prevent carbon dioxide or nitrogen oxide from being emitted into the atmosphere. Cleanup and restoration of damaged ecosystems. Strategy 3. Extracting and removing the pollutant from the ecosystem. Through high technology, it is possible for carbon dioxide to be drawn out of the atmosphere and sequestered or stored underground. Cleanup and restoration of damaged ecosystems. Strategy 3. Replanting and restocking with plant and animal populations. In this image, we can see reforestation, replanting. Replanting trees following degradation of the ecosystem. Planting trees serves to remove carbon dioxide from the atmosphere, reducing the impact of climate change. Cleanup and restoration of damaged ecosystems. Strategy 3. Replanting and restocking with plant and animal populations. In this image, we can see reforestation, replanting trees following degradation of the system. Planting trees serves to remove carbon dioxide from the atmosphere, reducing the impact of climate change. Most of the world's scientists think that human activities result in more greenhouse gases that results in changing the climate. But some people think that any change in the Earth's average temperature in recent times is nothing more than part of the natural cyclical change that the Earth has experienced over millions and millions of years. Some people think that while there is more carbon dioxide in the atmosphere, human activities are not responsible for that increase. Some suggest that the magnitude of the Earth's systems is too immense for humans to have an impact. There are varying value systems on the subject of climate change. Some people with a Western capitalist value system or a technocentric value system might suggest that we continue to drill for oil and burn fossil fuels. Some technocentrists would argue that we can fix climate change through massive geoengineering projects. More on geoengineering in Part 8. Ecocentrists might focus on the plight of certain species as the climate changes, arguing that people must find alternative energy sources. Ecocentrists might argue in favor of Gaia, that climate change disrupts the self-regulating system called Gaia. The anthropocentric view might cut either direction. Someone might argue the economic harm done to societies if we limit fossil fuel combustion, while another anthropocentric view might note the economic harm done by the last strong hurricane. Many people are invested financially in the fossil fuel industry. These people wield political clout with money and alternative facts. The technocentrist might argue that we have the technology to filter coal emissions or remove carbon dioxide from the atmosphere. The anthropocentrist might argue that people working in coal economics will be harmed financially. Or would an anthropocentrist argue that coal is harming people's health? And this is the IB syllabus statement that I'm following. There has been significant debate about the causes of climate change. There has been significant debate due to conflicting environmental value systems. Some people follow political values without thinking for themselves. Can you evaluate contrasting viewpoints on the issue of climate change? From the Department for Environment, Food and Rural Affairs in the UK, we can see some current perceptions that people have. And this is where we want to be. Take some time to study this slide. And as the world warms, are we taking notice of the increase? Can we discern the difference between weather and climate? Too often, a cold day in the summer leads people to suggest that the Earth's average temperature is not increasing. Too often, we latch on to 2 or 3 observations to support previously held beliefs. We need to be listening to our scientific community, a group of people doing their best to understand the changes at the scale of the Earth. Feedback effects are difficult to predict, leaving room for political values to insert themselves. But shouldn't we be cautious before foolishly continuing with the status quo? This is the precautionary principle. When extensive scientific knowledge on an issue is uncertain, actions should be cautious to ensure minimal harm. Better safe than sorry. And that brings us to the end of IBESS Climate Change and Energy Production, Part 6.